Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudewa Sos Ukobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4. It says the flow diagram below shows the preparation of different organic compounds using CH3CH double bond CH2 as a starting material. X, Y, and Z and P represent different organic reactions. Then 4.1, they are asking to which homologous series does this compound here belong? Right. Now we can see with that double bond here that obviously this belongs in the alkene homologous series. So it is alkenes, right? Then 4.2.1 says write down the type of reaction of which X is an example. Now let's look at X. We are moving from an unsaturated compound to a saturated compound, which is a haloalkane. So from unsaturated to saturated, we know using USA, SSS, and SUE, we know from unsaturated to saturated is addition, right? And then 4.2.2 says the structural formula and IUPAC name. Note, structural formula and IUPAC name of the alcohol produced during reaction P. So as we can see here, if this is moving from a haloalkane and then to an alcohol, we have another, we have a substitution reaction, meant to say, which is known as the hydrolysis reaction. Now we know that in a substitution reaction, it's just a matter of replacing the Cl here, chlorine, with the OH to form alcohol. So now if we have to draw the structural formula, this is CH bonded to 3 hydrogens and then followed by a C bonded to a hydrogen. But this time around, it will be bonded to an OH instead of the chlorine because we are forming an alcohol, right? And then now lastly, we have a carbon bonded to 3 hydrogen atoms. Then that's how we're going to have it. And therefore, what is the name of this compound here? It is propan-2-ol, right? So propan-2-ol. And then 4.2.3 says the type of reaction of which Y is an example, right? Of which Y is an example. Now we are moving from a saturated compound, which is an alcohol, and we are going to an unsaturated compound, which is an alkene. Now from saturated to unsaturated, we know that that is elimination reaction, right? But now, okay, so 4. Elimination reaction. So we are not required to be specific about that. So just elimination reaction. Then 4.2.4 now is asking for the function of the acid in reaction Y. What is the function of this sulfuric acid here? We know that it acts as a catalyst. It acts as a catalyst. Or you can say it acts as a dehydrating agent. Right. It says for reaction Z, write down the name of the inorganic reagent needed. So this is a reaction Z. Then what is the inorganic reagent that is needed there for 4.3.1? We're going to say we have to react this with sodium hydroxide. Sodium hydroxide. So note that if we are moving from a haloalkane to an alkene, what we are actually, the reaction that we are having there is dehydrohalogenation. Dehydrohalogenation. Right. So this is also an elimination reaction here. Now for 4.3.2, they say 2 reaction conditions needed. What are the 2 reaction conditions needed for dehydrohalogenation? We know that we need concentrated strong base since it's an elimination reaction. So that's concentrated strong base. And then as well as heat. So we need that strong heat there. And then that's how we have it. Now for 4.3.3, it says, write down a balanced equation for the production of the alkene using structural formulae. So for this compound Z here, let's indicate how it happens. So that means we will have our haloalkane. It's like this. We have our chlorine there, our hydrogen here. Then like that. Then it reacts. We said it must react with sodium hydroxide. And then this should give us the products should be H. But then remember, this is an elimination reaction. So that means we must eliminate the chlorine and then also eliminate the hydrogen from a carbon that follows there. Remember, we cannot take the chlorine and the hydrogen from one carbon. So in between those two carbon atoms, we're going to have our double bond forming there. So this is the major product that forms. Then when we take out these ones, the chlorine will react with sodium to form sodium chloride, and then the hydrogen will react with the OH here to form water. So this are our two byproducts, and then this is how we have our balanced equation for 5 marks. And okay, with all that being said, guys, we have came to the end of the lesson. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. And if you are watching from Facebook, please follow the page and like the page. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.